Today we're going to take a look at how we can use the AP Picture Lab project. So we can do some really cool manipulations of pictures and how we can actually look at how we can work with colors in new and fun ways. So we're working inside our project right here, and as you can see, I'm inside my picture.java where all the logic happens when we're talking about picture manipulation using the AP Picture Lab. We made a private method right here. I'm calling it get average color in row range. It takes as parameters a 2D array of pixels and a row, a start call, and an end call as its parameters. And so that's we can actually grab the information from the supplied 2D array that we're working with and make that happen. So the first thing we do when we're talking about working with a method, because this is a return type method, in this case color, the first thing I do when I write the method is I write color average color equals null. That gives me a default value that's good to go. It's compilable, it's automatic, and my last thing the next thing I write when I'm writing my method is return that variable I just declared and initialize to a valid value. Now I never want to actually set the color to be null, but I have a compiled value so it's actually good and ready to go from out that. So that's why I'm doing that specifically to start off, trying to use good coding practices as I go through that. The next thing I'm doing, because I'm getting an average color in a row range, I'm creating values for Java's way of handling red, green, and blue. In this case, I have ints for red, green, blue, and count, because when we're dealing with average, oh, that's right, I have to keep track of the count. So I have that value right there as well to initialize with 0, because again, when we're dealing with local variables, we always need to initialize every local variable because they don't have a value until initialized inside a method. Then I'm doing my bounds checking. Now my bounds checking is this if block right here starting line 235. And as you can see right here, I check to see if start call is greater than or equal to 0, and if start call is less than in call, and in call is less than pixels sub 0.length. So the first thing I'm doing is I'm checking to make sure that all the bounds I'm working with, aka every call I am, is from here to here, is totally in bounds. It's totally okay and great. Then I also check another and block that row is less than pixels.length. My row that I'm looking at is a valid row. I want to make sure that every time I'm doing this, I'm always doing my bounds checking first. You want to bounds check before you do anything in 2D arrays, before you do any access or logic, because if you bounds check first, you're good, you're safe, and then any logic you have and you work with is going to be safe and automatically not throw an index out of bounds exception, which means everyone's happy and good. Then we have inside that if block, I'm doing my for loop. And so my for loop, I'm going to check to say if call is equal to start call, and then call is less than in call, and call plus plus. So I declare a local variable call that can go through and iterate over the 2D array that we're working with. My row doesn't change, so I don't have to make a nested for loop on this because my row is the same every single time. And then we have to make sure we're doing the proper calculation of our average color. Now you'd think, oh, I'm just going to average the color out, so I'm going to get the red plus the blue plus the green, or the red values, add them together. But no, because of the fact that we use a square root and a square when we're actually working with colors inside digital imagery to help reflect the logarithmic way we see color as human beings, as well as how we store the information, maximize the way we work with that information of logarithmic storage of data, we want to make sure we handle that inside our code as well. And so we're going to assign to red, instead of plus equals get red, we'll assign it math.pow, passing it pixels sub row sub call dot get red, and then 2, which squares the value of the current red, squares it, adds it to the value. Same thing with green and blue. My count goes up by 1 as well. So now I've summed the squares of all of my colors I'm working with. Then I'm going to go and grab as a new value, I'll assign back into red, green, and blue, the cast down version of int of math.square root, passing it red divided by count. So I'm going to do the sum squares divided by the count and then do the square root of that. And so that way I can actually correctly calculate the values from my average, and it makes it look so much nicer. There's some great YouTube videos that go over the logic and the physics on this. Take a look at those. Have some great things you can use to make that happen. Then when I've got those red, green, and blue values that I've calculated, I'm going to assign a new color of average color, the one I declared up here earlier as null, but I'm making a new color passing those new properly calculated red, green, and blue values, and return that average color. Now that I've got the actual logic for getting the average color in that row range, let's take a look and see how we can make that happen inside our partial average in row. And so this is a way we can make it look so a little bit funny. It's kind of fun, but we'll take a look at that. So my public method is the one I'm going to use the tester to work over. And as you can see right here, I have a public void method, partial average in row. Just like we do in all the other filters we've created as part of the AP Photolab project, we're going to get the pixels for this by doing pixels 2D array, pixels equals this dot get pixels 2D. Same thing we start with all of our other methods. And I'm only going to work on the last third of the image. So I made the creatively named last third variable is equal to the cast down value of int of pixels sub 0.length times 0.6667 to get the last third of the picture that we're working with. Those are the columns I'm working on. And then for int row is equal to 0, row is less than pixels.length, row plussing. And then I'm going to get color average equals get average color in row range, the method we just looked at, passing it pixels, the 2D array we're working with, the row we're working with right now, the value we're working with, the int last third, which is the pixel group I'm talking about, and then pixels sub 0.length minus 1, because that's the last spot I can talk to when I'm working with this. And then we go for int call is equal to last third, call is less than pixels sub 0.length, which is guaranteed automatically to work because we're inside bounds. And then call plus plus, I'll do pixels sub row sub call dot set color, passing that average that I just calculated. So let's go ahead and take a look and see how that's going to look when we run the actual program. Let's go to PictureTester.java. As you can see right here, I have a public static void test partial average, and picture wall is a new picture wall.jpg. And this is the image if you're working with the AP photo project. It's the graffiti art of Michael Jackson on a brick wall. Really pretty picture. And we'll do wall.explore to show the picture the first time. And then we'll call wall.partial average in row so we can run our filter on that piece of that image. And then wall.explore to display the altered image, and so we can take a look at that. So we'll go ahead and hit play and see what happens. Say OK right there. And here we have the original image that we're working with, the wall.jpg. As you can see right here, it's this unaltered image of the Michael Jackson art. And then we have our partial filter where the last third of it has been averaged. Look at that. That looks so cool. You can see the fact that we have those lovely grays right here matching the grout of that wall tile. Looks really cool. We have the cool purple heading right here because that purple hits on that section right there that adds to that average color right there. It's an amazing piece of art that we can do with this and show some really cool effects. And so again, to make that happen, all we have to do is we have to calculate the average color by adding up the squares of the color that we're looking at, because that's how we store the actual color in a digital image, and then square rooting the average of that. So we can grab that sum squares and do the square root of that, and we can calculate that, get the cool average of that, and then put it into the picture by, in this case, only going over the last third of the image to create that. So it's a great way you can do some really cool fun stuff, make a good project, and make some cool things. As you can see, if I collapse my code right here, I've got that for average in rectangle, circle, and in column range, and testing those out in other ways as well, so you can see some really cool effects. And so if I run and do my changes right here, and I've got wall.jpg again, I'll average in color and average in row and rerun them together. And now, there's it with using it over that column. It's a cool effect over the middle right there. And then combining the two effects, we have this image right here. And so you can do some really cool stuff with this. So you can see some amazing art on that. You can do some really cool effects. Great way to do some cool creativity with using Java and computer science. I hope this is helpful for you and you get a better understanding of how to work with the 2D array and how to manipulate pictures using code. Thanks again. Have a great day. We'll see you next time. Thanks. Bye-bye.